Hello, everybody. How are you doing today? Well, today we're going to look at Chapter 5.2, the extension of it. This is going to be graphing proportional relationships, okay? And we're going to be looking at a couple different parts of this concept. We're going to look at proportional relationships being displayed in a ratio table, like the one you see to your left. And also we'll look at proportional relationships that are being graphed on a coordinate plane. And we'll take you through how to tell by using either the graph or the table, how you can identify what is a proportional relationship and what is not a proportional relationship. Okay, so to begin with, there's a few things. If you look, the structure in the ratio table on the left shows why the graph has a constant rate of change. As you can see, the y values are increasing by 2, and the x values are increasing by 3, but that's not it. I want you to look at something a little bit more closely. When I take the x values, we'll say, and I divide it by the y, I'm going to get 3 over 2. And if I do the next one, 6 over 4. If I take 6/4, that's the same thing as 3 over 2 as well. And then if I take 9 over 6, and I divide these both by 3, again, I get 3 over 2. And finally, if I get 12 over 8, and I divide these both by 4, again, I'm going to get 3 over 2. By taking like your x value and dividing it by your y value, you're going to be able to look at the ratios being, the ratios created by the table or displayed by the table, and you can tell, are these in a proportional relationship? And if the x over y simplified is the same all the way through all of them, then you know that the table is displaying a proportional relationship. The other one, if you have it as a graph, the graph of every proportional relationship is a line through the origin. So if in the origin, as you probably will remember, the origin is at 0, 0. So if our line that's being graphed on here, if it goes through the origin, it is considered a proportional relationship. Or another way of looking at it is, if my x and my y are both 0 at the same time, if when x is 0, y is 0, then it is a proportional relationship. So let's just take a look at this. I'm going to look at the table again. And I just want you guys to get comfortable with this. If I'm looking at my y values, you see plus 2, plus 2, plus 2. Let's say I'm going the opposite direction. I start at the 8, and I go 8 minus 2 is 6, 6 minus 2 is 4, 4 minus 2 is 2, and 2 minus 2 is 0. And I take 12 on the x values, and I say 12 minus 3, notice the 3 right here, 12 minus 3 is 9, 9 minus 3 is 6, 6 minus 3 is 3, and 3 minus 3 is 0. So as you can see, both the x and the y are both 0. Again, if you have that being the case, then you know that you have a proportional relationship. Okay? We're going to go ahead and move forward. Okay, now, in this first example, what's going on is the directions tell you determine whether two quantities are proportional. Okay, so it says use a graph to tell whether x and y are in a proportional relationship. So what's going to happen here is you're going to start off with a blank graph. Like you're going to get a graph, but nothing's going to be plotted. And you will take the x and the y values and plot them. Now remember, when you see the x and y, here we see for part A, we have when x is 2, y is 6. That makes an ordered pair of 2, 6. That means I'm going to go on the x-axis, this line right here, and I'm going to go over 2. And then I'm going to look at the y-axis right up here. And I'm going to go up 6. So I go over, I'll say over 2, and then I'm going to go up 6. And that's where my first point goes. The next one, right here, 4 and 8. It's telling you that I'm going to start off at 0. I'm going to go over 4, and then I'm going to go up 8. Hopefully you get the idea. That's how you plot these points if you've never done this before. And so you'll plot the points. Notice when I plot the point, when x is 0, what is y? Well, y is 4. Therefore, again here, I'll just write this here. When x is 0, y is 4. That means they are not in a proportional relationship. And you can tell on the graph, since it does not go through the origin, these are not in a proportional relationship. Okay, so for part B, I'm going to graph my points the same way I did in problem B. In problem B, I'm going to graph these the same way as I did with problem A. And I have 1, 2. That means I'm going to go over. Now notice it goes 0, line 2, line 4, line 6. That means this is really a 1, 2, 3, 4, 5, 6, 7. So I'm going to go over 1 and up 2. The next one is 2, 4. I'm going to go over 2, up 4. I'm going to graph this. But notice, it goes through, the line goes through the origin. Therefore, and also notice, as I'm subtracting these, I go from 3 to 1. 3 minus 1 is 2. 2 minus 1 is 1. 1 minus 1 is 0. Okay? And then up here, 6 minus 2 is 4. 4 minus 2 is 2. 2 minus 2 is 0. Again, I'm at x 0, y 0. Matching the graph is at 0, 0 at the origin. Therefore, these are in a proportional relationship. All right, we're going to go ahead and flip our page over. And you have 2 problems. Kind of how I mentioned before, how the graph will be blank. I want you guys to go ahead and plot the points from the table onto the graph and then determine whether these are in a proportional relationship or not. So I'm going to give you a moment to do this. Okay? Okay, so let's go ahead and take a look at these ourselves. And hopefully the whole graphing thing will make more sense as we go through this together. So I have x1, y3. So I'm going to go over 1, up 3, which puts a point right over here. And then I'm going to go over 2, up 4. So I'm going to plot a point right here. Then over 3, up 5. So I got a point right here. And then I have one that goes over 4 and up 6. Right there. And if I was to draw a line to connect these, now you guys can use a straight edge. My line won't be nearly as good. My line's going to go up this way. And as you can see, clearly it does not go through the origin, which is right here. So this is not a proportional relationship. So I'm going to put not a proportional relationship. For over here, for number 2, I go over 1, and then I go up 0.5. And then I go over 3, and I go up to 1.5, which is right here. Then I go over 5, and I go up 2.5. And then I go over 7, and I go to 3.5. So really what's happening, let me just show you something. It's going down 0.5 for every one that we move over. Let's see. So if I go from 7 to 5, if I go over just 1 instead of 2, it's going to be at 6. I'm going to go down a half. That'd put a point right over here. If I go at the 0.5, 2.5, then I go over to 4, and it'd be 2. If I continue doing this, where my 1 is, I go down a half, it's going to put me right over at the origin. And so if I draw my line, sorry, I don't have a straight edge, it looks like this. And so this is a proportional relationship. This is a proportional relationship. All right, let's go ahead and move on. Okay, for this next section, you're going to be given a graph that is proportional. And what you're going to be asked to do is to identify or to explain, interpret what each of the plotted points represents. So as you can see, I have a plotted point for 0, 0, for 1, 1.5, and then 3, 4.5. Let me go over what I'm most interested in that you know how to do. I want to make sure that you know what each point represents. So I see for 0, 0, the rover travels 0 inches in 0 seconds. That's what I want to know that you know. For 1, 1.5, the rover travels 1.5 inches in 1 second. Now, it is important to know that the rate is 1.5 inches per second, but I'm not going to make you rewrite that. Hopefully you understand that that is now going to be the unit rate, but I'm not going to make you write that. The last one you see here, 3, 4.5, yes, as you can guess, the rover travels 4.5 inches in 3 seconds. That is what I want you to identify. So when you're doing these, I want you to identify specifically what does each of the points represent. So I'm going to move on to the next part here. You're given 2 more graphs, and I want you to interpret the plotted points of the graph. Okay? Go ahead and begin now. Okay, so we're going to try this a little different way this time. I'm going to try to save you a little bit of time so you don't have to watch me type and write everything in. So we are to interpret each plotted point of the graph of the proportional relationship. So we knew that each one of these represented a proportional relationship. As you can see, they go through the origin, so you knew that was the case. So for for number 3, we had to look at the 3 ordered pairs, and this is what we noticed. We noticed that we have the point, or we have the point 0, 0. This represents $0 earned after 0 hours. We have 115. This is $15 earned after 1 hour. And then we have 460. This is $60 earned after 4 hours. Okay. Then for number 4. Again, we're looking at those 3 points. At 0, 0, we know that after 0 seconds, the balloon raised 0 feet. And after 1 second, the balloon had raised 5 feet. And after 6 seconds, the balloon raised 30 feet. Now, this is a technicality, but I don't know if this means how much it's increased at any given point or from the ground. I don't think that really matters too much, but that's basically the rate of which the balloon is increasing. It's going up at a constant rate. But hopefully that made some sense to you. Let's go ahead and move on to our next section of questions. Over here, our directions tell whether x, oh wait, hold on. All right, I'm getting ahead of myself. Yes, so we're going to tell whether x and y are in a proportional relationship. If so, find the unit rate. Now, I know I jumped the gun a little bit. You'll understand in a few minutes why I was beginning to say something and I stopped myself. But for now, follow those directions. You're going to tell whether x and y are in a proportional relationship. If so, find the unit rate. Remember what I told you in the very beginning of our video. You didn't have to graph the table to know if it's in a proportional relationship. Okay? So I want you to take a moment. Maybe you need to go back and look at your notes. But I want you to consider, is this a proportional relationship? How do I know for sure? And then for number 6, it says, let y be the temperature x hours after midnight. The temperature is 60 feet at midnight and decreases 2 degrees every half hour. Let me ask you to do this. For number 6, go ahead and make a table, and then using that table to determine whether it's a proportional relationship. Okay? So I'm going to go ahead and pause you guys while I get the answers prepared, and you're getting them prepared, and we will meet again here in a few moments. Okay, it's time to go ahead and look at this. Let's look at number 5 first. Again, we're looking to see is the data in the table for number 5, is this in a proportional relationship, is x and y? And so, if you recall, we talked about this in the very beginning. If I look at x, the ratio of x, y simplified, all of these are fractions, aren't they? 1/5, 4/20ths, 7/35ths, 10/50ths. If I write these simplified, they need to all be the same to be a proportional relationship. Okay? So 1/5 is simplified. I can divide 4 and 20 both by 4, making this 4 divided by 4 is 1, 20 divided by 4 is 5. So far, so good. I can divide 7 and 35 both by 7. 7 divided by 7 is 1. 35 divided by 7 is 5. And finally, I can divide 10 and 50 both by 10. 10 divided by 10 is 1. 50 divided by 5 is, 50 divided by 10 is 5. So, if we look at the x, and again, if we look at the x values, for every 1 x goes up, y is going up by 5. So if I subtract 1 from the 1 here, it gets me to 0. If I subtract 5 from the y, it gets me 0 as well. So I am at 0, 0. So with that being the case, I can say that x and y do form a proportional relationship, and the unit rate is 5 feet per hour. Hopefully that makes sense to you. Okay, for number 6, it's a little bit different. As I prompted with you guys, I told you to go ahead and make this into a table, plug in your values. So, this again, if you get this wrong, it's okay. This is practice. I want you guys to understand when we're done what you did here. This is the information we know. It tells us the temperature is at 0 degrees Fahrenheit at midnight. It decreases every half hour. So a half hour is the same thing as 0.5 hours. That's the same thing as a half hour. So I could jump right ahead and say at 0 hours, what is the temperature? After 0 hours has passed, what's the temperature? Well, we know we start at 60, so it's 60 degrees. After 0.5 hours, the temperature decreases 2 degrees, so it's now 58. At another half hour, now we're at 1, or 1.0, however you want to look at it. I'll put 1.0. At 1.0, that's really bad. Here, let's do this. There, 1.0. At 1.0 hours, it went down 2 more degrees, so now it's 56. And at 1.5, we go down 2 more degrees, and it is 54. As you can see, when x is 0, at 0 hours that have passed, y is at 60. They have to both be at 0 for this to be considered a proportional relationship. And so, our answer for this one, x and y are not in a proportional relationship. Hopefully this made sense to you. If it didn't, hopefully now that you've heard the explanation, now it makes some sense to you. So let's go ahead and move on to our next problem here. Okay. Again, I'm going to kind of prompt you through this. First, this is what I was starting to tell you earlier. I don't know why I did this, but go ahead and cross out the directions that are written right here. This has nothing to do with number 7. And I believe in it has nothing to do with number 7. I apologize for the confusion. So for 7, all we're doing is we're following the directions that are given in the problem. It says the graph of a proportional relationship passes through 12, 16, that's xy, and 1y, again that's xy, right? And it says find y. Now, I'm going to see if any of you can figure this out. It's very possible you're going to get yourself lost on here. What I'll tell you is this. Going back to our definition of what is a proportion is when a ratio equals another ratio. So if a ratio equals another ratio, what is another way of writing a ratio? Or what are ways of writing a ratio? I want you to think of that. You could have like 3 to 5. You could have 3:5. You could have a fraction of 3/5. So I will tell you this, and I'll see if you can figure this out. I want you guys to think of this in terms of the fraction ratios. And if these are proportionate, they should equal each other. So I want you to set this up as one fraction equals the other fraction. And then I want you to solve the equation. Give it a try, see what you do. And then once you've given your best try, you can go through and see how you really should do this problem. Okay, so I'm going to give you a moment to give it your own try just to see if you can figure this one out. Okay? Okay, so let's go ahead and take a look at this problem. I apologize if this was difficult. Let's see if you were able to come up with the way of solving this. So I guess To begin, we first have 12/16, which is x over y, is x and y. So we could do the ratio of x to y, so 12/16. And we're saying that it's equal to this other one, okay, which is 1 over y. So the way we can solve this is we can do our cross products. We can say 16 times 1 is 16. We can say y times 12 is 12y. And we can bring these down. So I have 12y equals 16. Okay? And now I have it as a equation like this where the fractions are gone. Hopefully this makes sense to you now. I'm going to have both numbers divided by 12 to get rid of the coefficient. I'm left with y. 12/16, it can be simplified. If I can divide 16 and 12 both by 4, I get 4/3. So the y value must be 4/3 to make this true. There's one other way you could do this if you wanted to. You could do it this way. You could say that 12/16. I need it to equal 1 over, well, something. We'll call it y for now. So what do we have to do? Well, how did I get from 12 to 1? Well, I divided it by 12. Right? 12 divided by 12 is 1. If I divide 12 by 12 to get 1, then I have to divide 16 by 12 also. And when I do that, I'm going to get 4/3. Because watch. 16 divided by 12 equals 4/3. So y must be 4/3. That's the other way of doing it. I don't know if it's any easier, but that is how you could figure out what our y value was based on the information that we're given. Okay? Hopefully that makes a little bit of sense to you. If not, no big deal. Let's go ahead and move on. We're going to be going through this a little bit later in this chapter, so hopefully at least this touching upon it will make more sense when we get to the section of solving proportions. Okay, this is the last part of our questions. It's going to be number 8. I believe this is it for us. And for here, it says you pay $1 to rent a movie plus an additional 50 cents per day until you return the movie. Your friend pays $1.25 per day to rent a movie. So part A, so we're going to do first. It says make tables showing the cost to rent a movie up to 5 days. So basically what I want you to do is I want you to make a table, and the table is going to have our x values, which we could call our days, and the other part would be like the cost. It should be through 5 days for each one of these. So I'm going to give you guys a moment just to set up your table, and it's going to be through 5 days and the cost through 5 days, and see what you guys can come up with, okay?
Look, Mummy, there's snow playing up in the sky.
Okay, let's go ahead and finish this up so we can be done, all right? So we were to make a table, and this is what the beginning of the table would look like. So we're looking at days and cost for both of the scenarios. So for our first scenario, it tells us that we pay $1 to rent a movie plus an additional 50 cents per day until you return the movie. So, after one day, let's think about what this cost would be. So after one day, you pay $1 plus the 50 cents. So the total cost would be $1.50. After 2 days, we have $1 plus we have to add 50 more cents onto this, so now it's up to $2. And so what happens is, as this goes to 3, 4, and 5, our costs are going to increase by 50 cents. So the next one becomes $2.50, then 3, then $3.50. That's how that table goes. Now for our other person, our friend, they pay $1 per day to rent a movie. So let's look. At one day, the cost is $1.25. That means at the second day, you're going to have 2 times this amount, so it's going to be $2.50. Or you're going to add $1.25. So as this becomes 3, 4, 5, I'm adding $1.25. So this becomes $3.75. This becomes $5. And then this becomes $6.25. So that's what our table would look like if we were creating a table that shows the cost of renting a movie up to 5 days. So, part B. It then says which person pays an amount proportional to the amount of number of days rented. Okay, well, let's take a look. As we've discussed before, in order to do this, our ratios need to be the same going all the way across the table. So I'm even going to make this obnoxious and just do it with decimals just to make it easier for you. So for here we have 1 over 1.5. Here we have 2 over 2, which is the same thing as 1 over 1, right? Here we have 3 over 2.5. Which is the same thing as if I was to double the top and bottom, I'd get 6 over 5. Although I'm not sure how much that helps you at all, but let's just look over here. Here I have 4 over 3. And I can't even make the bottom number a 5 if I wanted to. And then over here, I have 5 over 3.5. Now, again, if you wanted to, we could divide these all and make them over 1. Let's just take a look here. So we'll say for the first one, I have 1 over 1.5. This is the same thing as 2 over 3, right? 2 over 3 over here and 4 over 3. This in and of itself proves that these are not the same proportions. So I can always stop here if I wanted to. Or if I wanted, I think that's really enough to kind of prove this. So for A, that one does not work. Let's look over at the green over here. For the green, I have 1 over 1.25. When I do this, 1 over 1.25, I'm going to leave it like this just for the time being. Over here, I have 2 over 2.5. If I divide 2 by 2, I get 1. If I divide 2.5 by 2, I get, well, let's think 250 divided by 2 is $1.25. I get 1.25. If I have 3 over 3.75, and I divide them both by the top number 3, I'm going to get 1. And I'm going to make that over, well, 375 divided by $1.25. I'm sorry, 375 divided by 3 is $1.25 as well. And this is going to be the same case all the way through. And so for here, we want to decide, is this proportional? Well, yeah, it is. For every day that increases, the cost increases $1.25. And so if I subtract 1 from the first day and go to 0, and I subtract 125 from the cost below it of 125, I'm at 0, 0. So at 0 days, it costs $0. So I guess for B, we can go on and say, for part B, your friend pays an amount proportional to the number of days rented. And this is how we can prove it. Okay? I hope this makes sense. I know this was a long set of notes, but I'm counting this as your assignment as well. And so after you've done this, you are done with 5.2 extension, and we're going to move on to 5.3. So hope this went okay with you, and at this point you can go on and move on to your next set of notes. Okay? Have a good one.
Mother, do you think they'll like this song?